All right, 2013, number 6, we are given a dy dx, and part A is just asking us for the line tangent to the graph of f at a point 1 comma 0. So when I see something about a tangent line, I should always just immediately write y minus y1 equals m times x minus x1. And I'm given my x1. My x1 is just equal to 1. And I'm given my y1. My y1 is just equal to 0. So all that's left is m, and that's going to be determined by dy dx. And that's going to be determined by dy dx at 1 comma 0. So I'm going to plug in x equals 1 and y equals 0 to my dy dx to determine my slope. Dy dx equals, we'll say, e to the 0 power times 3 times 1 squared minus 6 times 1. Okay, so then dy dx is equal to e to the 0 is just equal to 1. And then we have 3 minus 6 is going to be negative 3. So we have 1 times negative 3, which is equal to negative 3. So that's going to be our m. So we have y minus 0 equals negative 3 times x minus 1. And that's the equation of our tangent line. So now it's saying, can you please find the approximation at x equals 1.2? So we're going to use this tangent line to approximate the output of the function at 1.2. So we'll do negative 3 times 1.2 minus 1. So then that's going to be equal to negative 3 times 0.2, which is equal to negative 0.6. So we have used the tangent line at x equals 1 to approximate the output of the function at x equals 1.2. Okay. Part B is asking for the particular solution through 1 comma 0. That is modeled by this slope. So we're going to have to do separation of variables and integrate here. So we have to get all of our y terms on one side. We have dy divided by e to the y equals 3x squared minus 6x times dx. Got to integrate both sides. So there's a couple different ways we can think about integrating dy over e to the y. This is going to be the integral of e to the negative y dy. All right. Now, technically, this is really a u sub problem. So we can say u is equal to negative y, and then du is equal to negative dy. So if we replace our negative y with u, we want to be able to replace our dy with our du. So we need to get dy by itself. So it would be negative du equals dy. So we could think of this as being the integral, negative the integral of e to the u du, which is going to be, well, the integral of e to the u is just e to the u. So we get negative e to the u. And then what was u? U was negative y. So this is negative e to the negative y. All right, so the integral of e to the negative y is just going to be negative e to the negative y. And then that's going to be equal to the integral of this side. Integral of 3x squared is x cubed minus integral of minus 6x is going to be minus 3x squared plus c. All right, so you can always try to solve for the plus c after you've already isolated y, but in this case it might be easier to solve for the plus c now. So we know that x is 1 and y is 0. So we have negative e to the 0 equals 1 cubed minus 3 times 1 squared plus c. So then negative e to the 0 is just going to be negative 1, and that's going to be equal to 1 minus 3 plus c. Okay, so then that means that we have negative 1 equals negative 2 plus c. So then c is just going to be equal to positive 1 if we add 2 to both sides. So then that tells us that we have negative e to the negative y equals x cubed minus 3x squared plus 1. And now we can solve for y. So we should multiply by a negative on both sides first to make this positive e to the negative y. So that's going to be negative x cubed plus 3x squared minus 1. Just flip all those signs. Now to undo the e to the, we're going to have to do the natural log on both sides. So if we natural log the left, the e cancels. If we natural log the right, we just have natural log of negative x cubed plus 3x squared minus 1. And then last step is just to multiply by a negative on both sides to make this positive y. So then y equals negative the natural log of negative x cubed plus 3x squared minus 1. Okay, that's it.